also have another eminent speaker, Dr. Eby Prasad, who is the Principal Cybersecurity Lead of Vidyatech. So I think over to him as the last speaker of this session.
So thank you for having me. And thank you for giving this opportunity to speak on the topic data sovereignty and secure AI architecture. So before we begin, we all believe that AI revolution is going on and it is here to stay. So once we speak about AI, the thing is it is at a higher level, like it's the topmost level of everything. So we have to think on what AI actually works on, and that is the data. And this is where data sovereignty has to come in, which means the control over the data that we are using. So in, let's say, a few years back, we would say a data sovereignty can be achieved if we have control over the server where the data is lying and the server is within our geographical area. But now the concept has entirely changed. So right now, what data sovereignty encompasses is data, compute, and AI should be in control. So it is not only the data that is lying in your server, but who is going to work on that, or what is working on that particular data. And also the AI module that is taking the data and utilizing it. This should also be taken into account. So once again, we have to look at who controls it, who computes on it, and this will govern the outcome. And why does data sovereignty matter? So with the coming of cloud, AI, and other global platforms, the data boundary has been blurred. So right now, data flow can happen over geographical boundaries, and it could go from one person to another. So it is kind of unrestricted. And with the AI systems coming into play on full force right now, it will amplify the data risk that is at scale. So what is data localization and flow? So if we think about these two terms, we will think about two different things. We might think that data localization means it is available locally, and flow means it is going out. And we have to have control over both of these entities or these two topics. But the thing is, it is not two. It is a false binary, which means not all data require the same set of treatment. Some of the data can lie in our environment and some can flow. And the real issue here is the classification and risk triaging of the data. So let's say you have a sensitive and regulated data, and this must remain sovereign. And other data that are not sensitive can flow out, but there is a cache that should flow out only with different policies, encryptions, and with accountability measures in place. Now, what makes a cloud sovereign? So usually, if we say something is sovereign, if it is in our control. And earlier, it used to be, like I said earlier, it's a server that is lying in your environment or in a protected environment and within your boundaries. But right now, the concept has changed. So right now, in order to establish a server is sovereign, we have to look at something like judicial, legal, and operational controls. And there should be a transparency in the operation on what the server is doing. So it brings us to a concept where there is a sovereign AI. But in order to achieve this sovereign AI, it should have a sovereign infrastructure. So if there is a non-sovereign infrastructure, you cannot have a sovereign AI. Now, where will we start the trust? Where will we start to trust the data at? So there is something called compute layer, where it is the root of trust is established. And this usually starts from the hardware layer. So your hardware gives the root of trust. And your data that is at rest and in transit are usually looked upon for security measures and how it is being processed. But right now we have to look at compute itself. That means the time at which this particular data is being processed. So this brings the focus on to encryption in use. Usually we have encryption at rest and in transit, but now we have encryption in use, which is during the compute of the data. And for doing this, we have something called secure enclaves. And secure enclaves are like co-processors that sits with the main processor and then takes the data, separates it, isolates it, and then do the compute and gives it back to the main processor. So using secure enclave makes it such that it will protect against the insider threat. Not even the admin, not even the hypervisor of an OS, or the OS itself cannot see the data that is being processed. And then we also have to have a supply chain trust, where, like everybody has mentioned before, so the hardware that we get, it should be, genuine. There should not be any hardware with some malware installed or something hard-coded into it beforehand. Then we come to zero trust. Everybody might have heard about zero trust because of our current networking. And during the COVID days, everyone was into zero trust. It was a booming topic. And here as well, we need to have a zero trust on the data that we are having and the AI that is working on the data. So it's like never trust the data, the users, or the AI model, and the APIs that we use to connect to the LLMs. And zero trust has to be established there. So this means we have to also verify the data access, who is accessing the data, and the model on which the data is trained on. You have to look at the data which the model used for training, so that this will prevent the bias. Then you have to also have inference usage, where the model's output and the predictions, you have to also look at that, and you have to verify that, whether it's true or not. Then for establishing zero trust, like always, we have to have a least privileged access. We have to give the access to some person on a least privileged basis. Someone should not be given full access. He should give the least access to the data that he requests. Now we speak about governance in AI. So how do we establish governance in AI? So AI requires three things mainly. One is data lineage, model explainability, and audit-ready logs. So what is data lineage? Data lineage is like tracking the data from its creation to the end. So you will know who created the data, when did he create it, like the metadata stuff that is there. And then you have something like where the data went, and during this travel, who accessed it, and who tried to change something in it. And did the data change from one form to another, like let's say PDF to a Word document. So all this should be tracked in a lineage graph. So even if you create a small file, you should have the view from the beginning to the end, and also have visibility on who has access to the data as well, and on like read-write access, or is it just read, and all kinds of permissions that is given to the data. Then model explainability means the AI model that you are going to use or you are using, it should be explainable. Like what is in the model, what is it actually doing, what is the algorithm used in it, and what is the input data that is given during training, and what are the shortcomings of this particular model. Then you should have the audit-ready logs. That is by default, everywhere we should have logs. If something goes wrong, we can check what is happening over there in an in-depth scale. So with the governance of AI done, I have to say that with a sovereign AI infrastructure, what this means is it must enforce the governance automatically. A sovereign AI infrastructure must enforce the governance automatically. Now let's look about some of the challenges, implementation challenges to data sovereignty and the secure AI architecture. So one is legacy systems. And most of the legacy systems are not built for zero trust. So at that time itself, it's out of the scope, right? Then comes the fragmented geographical regulations. So data regulations in a country is different from the country next to it. And it's even different when we go continent to continent. So that's a challenge that we have to face. Then shortage of secure AI talent. So AI boom has happened in a really rapid phase, and we are having a shortage of AI talent now. And not to mention secure AI talent, somebody who can build AI from scratch in a secure way. Then comes the initial cost of sovereign infrastructure. So for applying all of these things, the cost of sovereign infrastructure will go up. But you have to think that cost of insecurity is always greater than cost of control. So this is a must for sovereign infrastructure.
Well, thank you so much, all the dignitaries on the dais. May we please have you together for a group picture.